Hello everyone, I'm really excited about this episode because this is one of the nicest ways to improve your code, to make everything go more modularly and better, is to not have code like this. So I'm going to show first what the problematic code is, and then we're going to have better code that does something better. So let's assume we're playing around in Django, but it could be really any API that we're producing in Python, Fast API or Ninja, whatever the heck. There's all sorts out there. So let's assume this is the get method of some viewpoints, and it's going to grab a list of burgers. So let's look at this thing. First off, it's overwhelming. It's doing a lot of things. As you can see here, it's getting filters, and it's doing the filter logic. Then it's grabbing the burgers, it's annotating whether they're delicious or not, and it's filtering them, and then it's serializing them, it's saving them. Oh, go away, little thing. Okay, and then it's paginating it, and then it's formatting it for response, and then it's sending it back. Okay, so what's wrong with this code? Well, first off, it's doing all of this logic in the list itself. Or in the view itself, sorry, I should say. And why is that a problem? Well, what if we wanted to duplicate any of this logic in another view, or just in another part of the code, like something internal we wanted to have, filter logic, pagination that we would sort of duplicate onward? Well, we could cut and paste it into a new view, but then we were maintaining, two different views with the same pagination code, which we'd have to change in two different places every time something goes wrong. So this is what I would say lends to brittle code, which is code that starts to become, when you change something, things break in 5 different places, or you need to change it in 5 different places to make sure it doesn't break. So, and that's what we don't want. So we want all the logic in one place. We want it to be simple. We want it to be single purpose. So I'm going to start to refactor this code. I'm going to take it apart a little bit. I'm not going to make you watch that part where I, literally type it out, but I'm going to start to show it to you in stages as it should be, at least in my opinion. And I welcome your feedback on this. So let's go with the first part of this refactor. Okay, so the first step, as you can see, is pretty simple, taking out this logic. We're extracting a single purpose thing, which is the filtering logic and the pagination logic into the burger filter and the burger paginator. So as you can see, they're pretty similar to these ones down here for the filter. The only difference, as you can see, is that the query set's actually being passed in and being filtered into this in the apply method. And then the paginator is pretty much, it's identical to this logic down here. So now I'm going to replace this code into this code. Okay, so just one change that I made up here. I changed it to length query set so we'd make the retain the same functionality. In the else statement, it said that it would make the page size the length of the serialized data. So one big difference with the paginate, it's now doing it on the query set. It's doing above, and the filters are being applied. So we have our unfiltered burgers coming in. We have our burgers by applying our filter, and then we have our paginated burgers by applying our burger paginator. This is really clear what's going on. We know, okay, it's being filtered, it's being paginated. Before we had to really kind of dissect the logic. And it wasn't a lot, it was like 10 lines of code each, so it was reasonably easy to dissect. But once you start to get into really complicated processes, then it starts to become kind of a nightmare when they're all together. You have to try to figure out what they're all doing. So, and we have one more place where we can optimize this, and I'm going to do that, which is in the handling of the response. And then we're going to super optimize it. All right, the first thing we're going to implement is, if you look at the response formatter, it's this if not any else's, but it could be basically an if-else branching situation which this can really descend into chaos if you have lots of branching inside of branching. So if you have like another thing inside of each format. But as it is, it starts to become kind of untenable, especially inside the view get method. So let's see what we're going to do about that. The first thing is, because we have something that varies, we have a format that varies. We have XML, we have JSON, we have CSV, we have HTML. One of the cardinal rules is to encapsulate what varies. So we know, okay, something is varying. The format which the response is receiving is varying. So I'm implementing this as an abstract base class, which is a class that if I tried to implement this on its own, so if I made formatter equals something like this, and I tried to run formatter.format, this would, exactly, well, thank you, AI. This would raise an error because the format's not implemented. So what is the point of something like this? Well, the point of something like this is we're going to implement children of this, and each one of them is going to use a format method that that does what these formats are doing below. So one of them is going to be an HTML formatter, one of them is going to be a CSV formatter, JSON, and then an XML formatter. And each one of them is being told, okay, when you implement the response formatter, you need to implement the format method. And so I'm going to do that now, and I'll show you the result. All right, now we are cooking with gas, because look what we got here. We got an HTML formatter, a CSV formatter, a JSON formatter, and an XML formatter. Now, if something goes wrong, if we have our software and a client complains, oh, there's a problem with the JSON export, or, we know something is going wrong either in the export part or in the JSON formatter. So this is a great way, but it probably won't be because all it's literally doing is returning the data. So, but by separating this, look how it's so simple to understand what each one of these is doing. We've implemented the format method, and we know this one's for XML, this one's for JSON. We've got it all implemented in a readable and understandable way. And that is going to replace this code down here where it's not 100%. It is somewhat clear because you're like, okay, format equals HTML. You can figure it out, but this says exactly what it is. It's the HTML formatter. So we're going to implement that down here. All right, we're kicking butt now because this is how the get method looks on the burger list view. Really nice. We could even condense this further, but I wanted to make sure that it was clear what was going on too, because we could just get the formatter by calling it like that, but that's a little bit of a weird thing. Some people don't know what code looks like when it looks like this, but this would essentially be doing the same thing to just get the formatter calling, this down here. We could just call it up here, and then we'd have the formatter right up here, like so. But anyways, in 3 lines of code, we're doing what was quite a few lines of code. And we have the formatters up here that are doing all the logic in the format method. And then we have the lookup here. And also something I forgot to mention is that we have the content type on the format, which is kind of cool because before we had to pair that down in the logic, whereas now it's actually paired to the class itself. So, and we could do that we don't even need to make this lookup. We could have some sort of lookup inbuilt into the formatter using a registry pattern, but I thought this is a little beyond the scope of this tutorial, especially because we're into minute 9 already. So, so I just made a little lookup table here. So if it's HTML, CSV, JSON, XML, or the default is the no formatter also, which I added. That does nothing because before we had, if it didn't match any of the formats, it would just return a plain format with just the data. So now it does exactly as it did before, but it's way easier to understand. There's one more step that we can take this though. Now I haven't done anything yet, but I've taken this and I've popped it into a base list view. And I'm going to be modifying this base list view to be generic. So we can not only have burger list views, but we can have fries list views, we can have pizza list views, we can have all the things we need. Okay, I hope I can get through this all in one video, but now you can see I've set up these class attributes here. Query set, filter class, paginator class, serializer class, and formatters, which is now defaulting to our lovely formatters. And a default format of none. And when it defaults to no value, it'll go to the no formatter. So this is when it gets in and sees that the formatters is not in this. And then the plural name is items, and so that's something I added here. When it says no, it used to say no burgers found, so now it'll say no burgers found in the burger list view. But if we implement the fries list view and just do fries, holy cow, fries filter, fries, paginator, fries serializer. Do you see what just happened? We literally just implemented a whole new view in like 5 seconds. So look how powerful this is. This is what you want your code to look like at the end, the implementation. Oh, I want to change the default format? I will. JSON. Oh, I want to change the, the paginator. Okay, I want it to be the special burgers paginator. Done. We've got a new paginator class in there that functions differently. This is the holy grail of what code could look like. Your client comes back for a new request to change something, and you do it in 6 seconds, rather than going through what was essentially a large web of code before and, puzzling over how to fix it. There is more I wanted to cover, but I'm not sure I even have the time. Like, for example, how the serializer fails without without the annotation. Which I wanted to show it's actually sometimes a better idea, instead of referencing models directly, like the Django model burger, to have actually a layer of abstraction in between that, where if you have annotations that need to be applied, you're going to apply them in that layer, and you can also make sure that the query set is prefetching and selecting related and doing all the important things in that layer. And the benefit of having that layer is that you don't even need to use Django at that point. If that layer is getting all the objects, then we could switch out Django with some other API, some other framework, and not have to change the methods that we're using, because we're using a layer in between. But that's for another time. So thank you so much for watching. I hope this has been an interesting video, and I hope that you enjoy writing good code. All the best.